Okay, so have a nice day, everyone. So in this video, we will be going to move on with the next discussion of the data structures and algorithm in terms of the topic of graph, which in the previous video we was able to identify or discuss the adjacency of the matrix. Now in this video, we'll move on into the adjacency list. So let's define first what is adjacency list. So in adjacency list, it uses a list for each vertex where each list contains the vertices that are adjacent to that vertex and that also represent a graph as an array of a linked list. So we can actually figure it out later on how does it work since when we say linked list, those are the nodes, series of nodes which connect to one another, connect, diba? And there is a start point and that connects to the first node and that must end by null here. That is a linked list. So this adjacency list that we will also use the representation. So let's try to check here. So the adjacency list of undirected graph, since we will check that in a series of lists. So let's try to put here all of the nodes. A, B, C, D, and E. Okay, we will try to identify each adjacency of that one since we will be going to put everything. What are those list of adjacency in that specific node? So from that A, what will be the adjacent of A? So the adjacent of A, that is, since we are talking to undirected, we have B, we have D, and C. So we can actually put here B, and that is, we can put that in a bucket of list and point. Next adjacent will be C. Next adjacent will be D. It's okay if it's not sorted, that is fine since that is understandable that they are still adjacent to letter A. So that won't matter. So now, next, it must, since we are using the list, it must point to null, by the way. So that must be like that. And let's actually move on to letter B. What will be the adjacent for B? So that here is it's A, D, as well as E. So we can put that here then. Letter A, that must be connected to D, and that must be connected to E, and that must be point to null since the last value in your linked list must point to null. Now, let's also move on to letter C. What will be the adjacency of C? That is A and D. So you can put, no. I'm so sorry. For letter C, that is A as well as D. So you can put that here, it's A and letter D. So that must point to null since there's no other adjacent anymore. So let's actually move on to letter D. So that is, they do have four adjacency. So that is C, A, B, E. So in this instance, I will just sort that out so that it will be arranged actually. But it won't matter if you identify that as unsorted in a unsorted manner that won't um what they call this one, that won't matter actually. So A, B, C as well as D, and that must point to null as well. So that's how you will go ahead and do that here. And how about for letter E? What will be the letter A? That is B as well as D. So let's actually just identify that, and that must be B connect to D. So that's how you will identify that one, and that must return to now. So that's how adjacency list work then. So that is simple than adjacency matrix. So anyway, there's nothing to worry in that then anymore. So just to also recap, in that particular graph right now, that this is the adjacency of list. So I wasn't able to identify here that must point to null, but make sure that you have that it must, the last node must also point to null, since that is how linked list work then. Okay, let's actually move on to the directed graph. So it will be the same thing, the same process that we will also do. So you have to put the letter A, the letter B, letter C, letter D, and letter E. So, so sorry. It must be A that is pointing. So you will just count still the outgoing order for that. You will not be going to count the ingoing arrows. So that is pointing to B as well as to C. So that is B, then that's B, then and C. So as what I mentioned earlier, that this must point to none of the same thing, since there were only two here then. So let's actually move on to B. So A is not adjacent to B, since I mean B is not adjacent to A, since there's no path B going to A. That is in going arrow, so that's not counted. So B is actually connected to D as well as E, so that's why we only do have two adjacent for that one. So we can identify that here as D as well as E. Sorry, D, this is C, huh? And must point to null. So sorry, because I am having a hard time here managing my mouse. I mean my touchpad in my MacBook. So sorry for that. So letter C, how many or what are the adjacent of letter C? So A is not counted. So D is counted, since that point to null to letter D. So that is only D for letter C. Letter D, ha, letter D. That is D. Let me reiterate. Sorry, letter D. And there's no other letter, so it must point to null directly. And let's move on to D. D is not connected to B, is not connected to C. So that is only pointing to letter E. So therefore, the adjacent of letter D is only E, that point to null. And here then, letter E don't have any value, don't have any adjacent, since this is in going manner or arrow. So there's no point, there's no relationship to B and neither to D. So therefore, it's only null here in letter E. So that's how it work for the adjacency list of directed graph. So I do hope that you actually learned something about this one. Same thing here, I wasn't able to put the null. So that is really important, since that's how linked list representation work then. So if you do have any question, you can also drop that in the comment section or just message me through my MS. Thank you so much.